7.2 is similar polygons. When we're talking about similar polygons, it's kind of like the same thing as a congruent statement. However, if I had a congruent statement that said triangle ABC is congruent to triangle XYZ, this is what it would look like. Now, if I'm saying that two triangles are similar, this part stays the same, the two triangles and the points that are similar. However, the symbol in between is just a squiggly line that's saying that they're similar. And we're going to go over some definitions here next. First, what are similar figures? Well, they're figures that have the same shape, so like this, but they're not the same size. But if we have similar polygons, that means the corresponding angles are congruent, but the lengths are proportional, meaning that this side length to this side length will give me the same fraction as this side length to this side length because they're proportional. Whenever you have three or more ratios that are equal, you can always write an extended proportion. We'll go over that. And scale factor, this is like if you're using a map, it's saying that 1 centimeter is equal to 15 kilometers on a map. That's what a scale factor is a ratio comparing measurements. So if any of those definitions are confusing to you, you should pause the video and make sure to write them down. So understanding similarity. First, I want to look at this similarity statement. This is going to help me solve these next two problems. It's saying congruent angles. So angles are always going to be congruent. So my M is written first, so that has to be congruent to my angle S. So angle M would be congruent to angle S. And you write your congruent statement here, not a similar statement, because they're the same. And angle N is my second letter written, so it's going to be congruent to my second letter written in my second statement. And angle P will be congruent to angle T. So what are the extended proportions for ratios? So again, I'm going to use my similarity statement. And if I look here, MN is written first. That's going to be paired up with SR. So MN over SR. So that's going to be one ratio of a side, saying MN is similar to SR, meaning there's a number that I could multiply MN by to get the length of SR. And that's going to be equal to the ratio set up by the other two sides. So here I have NP are my next two letters, so that should go on top because my first triangle is on top of my fraction bar. And that's in the same spot as RT. And then my last fraction or proportion would be MP, our first and last letters, and that's going to be proportional to ST because those are my first and last letters. So this would be the proportions for the ratio of the sides. All of these fractions, if there were numbers there, would all be congruent to each other. So these next two problems are kind of the same. I'm going to do the first one, and then you should pause the video to see if you can do the second one by yourself. Saying, are these similar? Well, I'm given all side lengths, so I want to see if their ratios are similar. And I'm going to use this information here to help me. It's saying AB. So if I look at AB right here, that's 15. 15 should be in the same spot as FE. So FE is right here. So I'm going to put 15 over 30. I'm checking all my proportions to see if they're equal to each other. Then I'm going to write a proportion for BC because those are my second two letters, BC. And my second two letters for the next statement is ED. So that'd be 17 over 34. And then I also have to check my last symbol, AC, which is 8 over DF, which is 16. And then I want to simplify all those fractions. So they all simplify to 1/2. So yes, the two are similar because all of their ratios are similar. Again, I want you to pause the video right now and try to see if you can tell if polygons LMNO and QRST are similar. When you're first looking at this problem, since it is a rectangle because all the angles are 90 degrees, I first wrote in that these two lengths are 10 and 4 and these two are 6 and 16. And since the opposite sides are congruent, I'm just looking at two proportions. So first I looked at LO because that's my first and last letter, and that has to be compared to QT, so that's 10 over 16. And then I looked at my second two, so ON and ST, that's the 4 over 6. So once I look at my reduced fraction, I have 5/8 is equal to 2/3. Well, 5/8 is not equal to 2/3, so those would not be proportional. Sad face. So now I say that I have two similar polygons and I want to set up proportions to help me solve this. First, I'm looking at this smaller trapezoid compared to this larger trapezoid. I'm looking for just x. So if I look at x right here, x is in the same spot as FG. So if I look at FG is the middle two letters, so I'm going to have BC and FG make a ratio. So BC is going to be 7.5, and X is going to be on the bottom. So now I want to compare that to two other letters, or two other sides, I should say. When I'm looking at this picture, I see that I have two lengths. Here's a 9 and a 6 to make a whole fraction. I don't want another variable in my second fraction. So if I look here, DE, if I look, is in the same spot as DA. So DA is 9 and ED is 6. So now I set up my proportion, and now I have a fraction equal fraction, and you should cross multiply here. So you would get that 7.5 times 6 is 45. It's equal to 9x, and divide by 9 on both sides, and you get x is equal to 5. Right now I want you to pause the video and try to figure out what y is. You'll probably be using this same ratio as your fraction with two whole numbers. And you should have gotten that y is equal to 3.3 or 3 1/3. So your ratio should have looked like 5 over y is going to be equal to 9 over 6 because y is matched up, EF is matched up with AB. We will be going over some word problems tomorrow in class, so be prepared. Have a great day.